So what are you guys?
We're the Swartwood family.
Hi guys, I want to do a quick problem posed by a student. But basically, in order to do this, it would help to be comfortable with some of the other problems that we've done before. So if you need a refresher, please go back and check out those videos. But what I want to do is I want to take numbers from 1 to 30, and we want to pick, say, let's pick 5. Okay? Let's pick 5 of them, and let's make sure that the difference, when we pick these numbers, these 5 numbers, we want it to be the case that the positive difference between any 2 numbers is going to be at least 5. Okay? So what I mean by that is if you pick the numbers, say, 1 and 6, that's okay. Because when you take the difference between them, I know it's -5, but the positive, take the absolute value, it's going to be 5. That would work. Okay? The difference between, say, 7 and 1, that is 6. That's also going to work. Okay? But the difference between, say, 3 and 4, -1, that is not going to work. So you just want to take 2 numbers, right? And when you take the absolute value of the difference of those numbers, you want it to be at least 5. Okay? So how many ways can this be done? All right, so at first, this looks kind of tough. And if you think about it, like trying to compute it, doing the standard stuff we do, it's a little tricky. But again, if you visualize it, right, think of it a certain way, it can make all the difference. And since we're going to do a series of problems called roundtable problems, this is going to help. This sort of thinking is going to help. So let's start with this. So rather than actually think about the actual numbers, because that can get really confusing, let's think instead about picking 5 correct ones. Okay, so let's call these 5 our picks. So you have 5 picks. Okay, all right. So you plop those guys down. Those are the 5 picks. And what we're going to do is we're going to imagine once we place everyone down, we're just going to order it always from 1 to 30. So and then what happens is when we put everyone down, we're always going to count from the left to the right, 1, 2, 3, all the way to 30. Okay, so I want to take our 5 picks and place them down like that. Then what I want to do is this. We need at least a difference of 5, right? Okay, so that means that between this guy and this guy, there are 1, 2, 3, 4 guys, right, that we're not picking. Does everybody see that? So for example, if this is number 1, 2, 3, 4, 5, 6, then the difference between 1 and 6 would definitely be 5, right? So in order for these 2 guys, right, to be at least 5 apart, you need to have 4 guys between them, okay? So just check that quickly. But now I'm going to force that right here, right here, right here. Does everybody see that? Okay. So what that means now is, all right, we've got 30 numbers. 5 of them we've plopped down for sure. 1, 2, 3, 4, 5. That leaves 25 numbers left. Of those 25 numbers that we're not going to pick, right, we have to place 4, 8, 12, 16 of them down. Okay? That means once we have this setup done, right, we've got 9 numbers left that we're not going to pick, and they can come from anywhere. They could be over here, 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 or there. It makes no difference, right? Because what's going to end up happening is, imagine you have the numbers here. Again, 1, 2, 3, 4, 5, 6. Okay. If we were to take one of our 9 remaining and just place it in here, it doesn't matter whether we place it here, here, or there, it's going to have the same effect. Because if we did this, and say we placed it right there. So then when we do our final count, it would be basically 1, 2, 3 for him, 4, 5, 6, 7. Okay, but if instead we place the guy right here, notice we're going to get exactly the same thing. 1, 2, 3, but now this will be 4, 5, 6, 7. All that matters is whether we place it here, here, or say over there, because that'll shift around the positions of the ones we pick. Okay, so the way to visualize it maybe is now this. We've got our setup, we've got our 9 guys free, right? And we can place them anywhere. We can place them right here, right there, 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 right? And you can place more than 1, you can place none, whatever, but you know how to do this. This is the old hat. It's literally like saying we have 1, 2, 3, 4, 5, 6. So if you're rusty with this, go back to the video we did. I think it was called like balls and boxes or something. But if we have 6 of these boxes, right? In order to identify the 6 boxes, we need to choose 1, 2, 3, 4, 5 dividers. So imagine placing those 5 dividers down. But then you also have to sit there and account for everyone else. So there are 9 guys, and we need 5 dividers to partition this out. It's going to be 9 like that. And then you can either choose where you place the 5 dividers or the 9 guys to figure out what this actually looks like. So I did that quickly, but that's in that video, balls and boxes. So the thinking is this right here counts the number of ways of placing these 9 guys into these slots, right? And then, does everybody agree? Once you put an arrangement down, so let's say we did this. 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Then we know exactly what numbers we have. And I'll demonstrate. So if we counted this off, this would be number 1, number 2, The P would be 3, so that would be one of our picked numbers. Then 4, 5, 6, 7, 8, 9. So 4 through 9 would be these numbers here, which we don't pick. Then we pick this one, so that would be 10. And then 11, 12, 13, 14. So 11 to 14 we don't pick. We pick this one, 15. Okay? And then 16, 17, 18, 19, 20, 21. So 16 through 21 we don't pick. And over here we pick 22. Sorry, I'm running out of room. Hopefully this is legible. And then we go 23, 24, 25, 26, 27, 28. So 23 to 28 we don't pick. And then we pick this one as 29. Okay? And then we throw away 30. Okay. So now you can definitely see our numbers are 3, 10, 15, 22, and 29. And then again, we have our 9 guys, and we place them down, right? 1, 2, 3, 4, 5, 6 containers, need 5 dividers. So this is it. Okay? So it's actually a pretty nice way of visualizing a problem like this, which otherwise I think would be pretty complicated.